Okay, let's have a look at a question with concentration equals moles divided by volume. And this applies to titration questions, so let's look at it together. It says, look at the equation for the reaction. 1 mole of NaOH plus 1 mole of HCl goes to 1 mole of NaCl plus 1 mole of H2O. The mean volume of sodium hydroxide solution used is 25 centimeters cubed. Brian uses 20 centimeters cubed of hydrochloric acid. The concentration of the hydrochloric acid is 0.100 moles per dm cubed. Calculate the concentration of the sodium hydroxide in moles per dm cubed. Now the problem with this question is when you look at the last sentence, calculate the concentration of the sodium hydroxide. If you try and put the figures above it into that equation, you'll quickly realize you do not have enough figures to work that out. So that's why it's a little bit tricky at first. So what you're going to do instead is you're going to draw out this table, and we're going to work out what we can work out first, rather than worrying about the answer there. So this table involves us putting HCl and NaOH in the two columns, and then in the rows we're going to put concentration in moles per dm cubed moles and volume in dm cubed. And then we're just going to work through the question. I'll go back to the top, and it says the mean volume of sodium hydroxide solution used is 25.0 centimeters cubed. And I am therefore going to put a 0.025 in there. Now you're going to say, well, why have I put 0.025? And that's because the conversion from centimeters cubed to decimeters cubed is always to divide it by 1,000. So I've divided that by 1,000. Now some of you might be wondering, why are we even bothering with decimeters cubed when most of our liquid reactions are centimeters cubed? And the reason is that a decimeter cubed is a litre, and a lot of experiments would have been carried out with a litre of gas, not smaller quantities in terms of the volume. So you're just going to have to convert it into decimeters cubed, which is 10 centimeters times 10 centimeters times 10 centimeters, which means that the conversion between decimeters and centimeters is to divide by 1,000. If you want to do it the other way around, you have to times it by 1,000. So I've basically just divided 25 centimeters by 1,000 in my head to give 0.025. Back to the question. The next line says Brian uses 20 centimeters of hydrochloric acid. So I'm going to put there 0.02. And that's the same scenario. I've just divided it by 1,000 and stuck it there into the table as follows. Third line of the question, the concentration of the hydrochloric acid is 0.100 moles per dm cubed. So I've placed that into the table there. And that's all the information that I've been given. You'll see that I'm struggling to work out anything with NaOH, but I can work out the number of moles of HCl. To do that, I just need to rearrange the equation. Concentration equals moles over volume, and the number of moles is going to be concentration times volume. So when I times 0.1 by 0.002, I come up with 0.002, and that's how many moles of HCl I've got. What I need to do next is work out the number of moles of NaOH, and to do that I need to look at the equation. As I look at the equation, it's telling me that 1 mole of NaOH reacts with 1 mole of HCl. And so this is really easy, in fact. If 1 mole reacts with 1 mole, I haven't got 1 mole, I've got 0.002 moles. So it's going to be obvious there that 0.002 moles of HCl is going to react with 0.002 moles of NaOH. So this is quite an easy question in that respect. Often there might be a 2 there, we might have to times by 2 or divide by 2 the number of moles. Okay. In this case, there's no need to do that. Also, sometimes there's dilutions to a factor of 10, but in this case, this ends up straightforward in that respect. So what do we need to do now to work out the concentration? Well, look, you can clearly see now that we now do know the moles, we do know the volume, we have memorized the equation, so it's just the moles divided by the volume, which is going to be 0.002 divided by 0.025, which is going to give us 0.08 moles per dm cubed.